Hello, this lesson is over significant figures. Significant figures of a given number are the important digits which contribute to the degree of accuracy of a number. Now, significant figures are important, especially when you're dealing with lab data, because they contribute to the integrity of a number. So if you display a number beyond the actual value that it was measured, you compromise the integrity of the number, which is obviously not good if you're conducting a lab where your results have to be very precise. So for significant figures, there are a couple of rules that you have to memorize. I made this visual over here, which so it helps you to understand what I'm talking about when I'm talking about leading zeros, lagging zeros, and in-between zeros and such. So the first rule that we have here is that all non-zero digits are significant. So in the number 573, all three digits in that number are significant. The second rule that we have here is that zeros between non-zero digits are significant, meaning that the 0 in 206 is significant. But lagging zeros are not significant. So we have the two zeros in 0.0534. The two zeros at the beginning of the number are not significant because they are leading zeros. Lagging zeros to the right of the decimal point are significant. So in the number 3.200, the lagging zeros in that number are significant. Lagging zeros in a whole number without a decimal point are not significant, so the 0 at the end of 5,280 is not significant. But if there is a decimal point with a whole number, that 0 is significant. So in 5,280 point, the 0 is significant. So there's a difference between these two numbers. And so there's kind of an analogy that helps you remember what zeros are important and are not important. So it's called the Atlantic Pacific rule. So it basically states that if a decimal point is absent, zeros on the Atlantic side, the right side of the number, are insignificant. And if the decimal point is present, zeros on the Pacific coast, the left side of the number, are insignificant. So I have a couple of examples here. So in 540, we're going to use the Atlantic rule for this. So there is no decimal point in this number, so the 0 on the right side, which is this 0, is insignificant. In the number 0.35, we're going to be looking at the Pacific rule, which states that if the decimal point is present, the 0 is on the Pacific side, the left side of the number, so this 0 is also insignificant. And for our last number here, we have 190 point, and we're going to be referring to the Atlantic rule here again. So we have if the decimal point is absent, zeros on the Atlantic side, which is the right side, is going to be insignificant. But since we have a decimal point right here, that means that this 0 is going to be significant. Now, when you learn sig figs, you also usually learn scientific notation with that, which just helps to solve numbers with very large or small magnitudes. And so scientific notation is denoted by n, which is your number, times 10 to the x, where x is any integer. So if you're trying to put a number into sig figs, where you see we have your x here, so we're going to write this out. So 5.73 times 10. So if x is a positive number, that means the decimal moves to the right. So our original number was 573. So in order to get that, we would have to move the decimal 2 places to the right. So it would be 5.73 times 10 to the positive 2. Now, the way I like to think about putting numbers in scientific notation, I think about it algebraically. Instead of like moving the decimal points, I just do it that way. I might be weird for it, but might help some people. So in my mind, I think 0.0534 is equal to 5.34 times 10 to the x. So I have to think of what value x would be to get this number, and that would be a negative 2, so x would equal negative 2, so the final answer here, which is technically not final answer, but it would just be 5.34 times 10 to the negative second. So on this slide, I just have some numbers here, so you can practice doing it on your own. Under this sheet, I have the answers, so I suggest that you do it yourself and check your answers with my answers. Alright, when you do math with significant figures, you're obviously going to have to round, because when you do mathematical calculations, they're going to go beyond you're going to have numbers, decimal points that go beyond the measured values. So rounding rules that we learned since like 3rd grade, they haven't changed yet, they keep the same. So if the value is greater than 5, then you have to round up the preceding number. If it's between 0 and 4, you have to keep the preceding number value the same. So for example here, we're rounding to 2 decimal places, so the first number would be 13.26. Next one would be 2.67. One after that would be 4.33. And the last one would be 35.30. So now it's time to get into the math. So addition and subtraction rules are very similar to each other. So for the rule for addition is that the sum should have the same number of decimal places as the limiting number, which the limiting number is the number with the least amount of decimal places. And for subtraction, the rule is the difference should have the same number of decimal places as the limiting number. So for first problem here, we have 20 plus 9, which is pretty straightforward. It will just be 29. The next one is a bit more complicated. So we have 25.4 minus 3.21. We have 2 sets of numbers with 2 sets of decimal places. So when we crunch that math, we get 22.19. But since this 2.1 goes beyond the 0.4 in the 25.4, we have to adjust for sig figs, so the final answer would be 22.2. And for the last one, when you have numbers in scientific notation, you want to make sure you take them out if you're going to do the calculations by hand, just to make sure your decimal points line up. And that's really only for addition and subtraction, because when you're multiplying numbers, then you keep the same amount of sig figs, so the rule is different, as you'll see on the next slide. So we have 540 plus 9.0, so we get 449, and we have to adjust for sig figs, because this 0 here is not significant, so the final answer would be 550. And lastly, here we have our multiplication and division rules. So the product slash quotient, they have the same amount of sig figs as the limiting number, which is the number with the least amount of sig figs. So for the first problem here, we have 8 times 9, which equals 72. We have to look at the sig figs of the 8 and 9, which they both have 1 sig fig, so our answer has to be 70. Our next answer here, we have 33 divided by 11. So we get 3, but we have to account for sig figs again. Both these numbers have 2 sig figs, so our answer would be 3.0. Next, we have 2.54 times 12. So when we crunch that math, we get 30.48. So we need to have 2 sig figs in our final answer. So our number would be 30 point because of that 12. Lastly, we have 126.5 divided by 260. When we crunch the math on that number, we get 0.486. One thing that you should get in the habit of doing is think about the sig figs while you're doing the problem. So, like, if you see this 2.6, you know your answer has to have 2 sig figs in it. So when you write down your answer, when you're showing your work, I would write down this number so you can basically see numbers that you would need to round, so the 6 and the 8. So when you do it, you don't forget, and you round your answer to 4.9. So that's all for this video. If you need any help with anything science related or math related, I can help you. My contact information should be in my video description and channel description as well. So if you need any help, reach out to me and I'll be happy to help you.